In this one, I want to answer the question, how can we tell if a table represents a one-to-one function? And because this is leading up to graph isomorphism, it makes sense that our tables have information about graphs. And the two graphs we'll use, although it really doesn't matter, are these two here, G and H. The domain of our functions is the vertices of G. The target of our functions is the vertices of H. Now on the left we have the function f1 from the vertices of G to the vertices of H. And we have the function f2 from the vertices of G to the vertices of H. Now, as a little review, let's determine why we know, in fact, these are functions. We know these are functions because notice that every element of the vertex set for G is listed here, and there are no repeats. So if all of them are listed and there's no repeats, then it's a function. Here, all of them are listed. There's no repeats, so it's a function. Now let's decide, is f1, represented by this table here, is that a one-to-one function? So graphing the points in the plane for my graph here, let's see, v1 goes to u1, v2 goes to u3, v3 goes to u2, excuse me, and v4 goes to u1. And now you can see that f1 does not pass the horizontal line test. So f1 is not one-to-one. Now looking at f2 over here, let's plot its points. Let's see, v1 goes to u2, v2 goes to u1, v3 goes to u4, and v4 goes to u3. And now you can see that f2 does pass the horizontal line test. So f2 is one-to-one. So now what is it about these tables that tell us that it's one-to-one? Okay, notice here that there are repeats. u1 is repeated. So repeats here, no repeats. So it's that simple. If you already know it's a function, then you can tell if it's one-to-one or not by looking in the second column and saying, are there any repeated values there? If there's no repeated values, then it is one-to-one.